Hi everyone, my name is Randy and today I will be leading an activity about rockets. Before we begin, I'd like to introduce you to Robert Goddard. My daughter made him. It's a bottle buddy that she made at Page Hilltop a few years ago. But I'd like to tell you a little bit about him. He lived from 1882 to 1945 and he lived most of his life in Auburn, Massachusetts. He attended Worcester Polytechnic Institute, or WPI, and Clark University, both in Worcester College. That's about 30 minutes away. He's considered the father of modern rocketry propulsion, was a physicist, a scientist, and an inventor. In 1926, almost 100 years ago from today, he constructed, built, and successfully tested the first rocket using liquid fuel.
As many of you may have learned in school or heard about, Isaac Newton had three main laws of motion, which were later coined after him. His first law states that a rocket will remain on the launch pad until an unbalanced force is exerted, propelling the rocket upward. This is the traditional "an object will remain still until a force is acted on it." His second law states that the amount of force depends upon how much air is pumped inside the rocket. You can increase the force further by adding a small amount of water, which increases the mass expelled by the air pressure in the rocket. His third law states that the action force, which is a force acting in one direction, of the air and water as it rushes out of the nozzle, creates an equal and opposite reaction force, propelling the rocket upward. This is the law that states that any object being acted on by a force will create an equal and opposite reaction force, pushing back on it from the other side. Other terms you may have heard about include gravity, which is a force that pulls everything down toward the center of the earth. Propulsion is the action of driving or pushing forward, and air pressure is the force exerted onto a surface by the weight of air. All of these terms have a direct relationship with this particular activity, so as you're building your own rocket, and as we show you our tested version, think about how all of these terms are used on the rocket and how these things affect the rocket's motion.
Hey everyone, I'm outside now, about to make my water rocket. So today we're going to use a 2-liter bottle. You can also use a 1-liter bottle if you don't have one, if you don't have a 2-liter, sorry. You're also going to need a ruler, a pair of scissors, a compass if you have a compass, that would be great. If not, you don't need it. We can do it with a pen or a pencil and a string approximately 12 inches long. Other than that, we're going to need some tape to tape on the fins to the side of the rocket. And I used the Cheerio box that I cut down the side for the fins. You can also use other cardboard that you have in your house. So we're going to begin with that. So the first thing I'm going to do is I'm going to make the nose cone. So you can first of all use a ruler if you'd like and measure the contour of the plate to figure out where the center is. And once you've figured out where the center is, you sort of move your ruler around and make sure it's equal all the time and you get the center. Another thing you can do is you can take your pencil or your pen, tie the string around it, and this actually will work better on a flat piece of cardboard better. And once you have a string with a knot in it, you can simply hold it on your piece of cardboard and you can try to do a circle like that. Sometimes these paper plates have a contour on them, or they have lines on the inside, and that helps you lay out the circle. So there's the circle. If you have a compass, again, you sort of have to figure out where the center is with your ruler, and then you start there by putting a hole in it, and then figuring out exactly where you want your nose cone, and then you just run your compass around like so. So we have a circle. Then we take your scissors and we're going to cut it. Just do your best cutting out the circle. Doesn't have to be exact. Perfect. And then we can recycle this. Now we have the circle, and with the center dot that you put in the center of the circle, which you want to mark, so that you go straight into the center, and that way your cone, when you close it up, you sort of fit it to the bottle. So in this case, we're going to put it on the bottom of the rocket, on the bottom of the 2-liter bottle, and I want to try to figure out where it needs to be. The bigger the circle, the taller the cone. So if this was larger, you could have it tighter and it would extend down. So that sort of depends on the larger the circle, the taller the nose cone. So, and then I'm going to take some tape. And I'm using mailing tape. It's nice and wide. It's a little bit easier to use than Scotch tape, but Scotch tape will work too. And I'm going to tape the nose cone. And I'm going to, once I get that, I'm going to cut the excess off a little bit. Fold the tape in. And then I will do another piece of tape, sort of on the inside on the other joint, and then fold it out. And then once I'm done with that, I'm going to tape the nose cone onto the bottom of the bottle. When you tape the nose cone on the bottle, you want to sort of start on one side and alternate, so you make sure that your nose cone is not tilted. It's upright, and it's sort of even all the way around it. Perfect. Awesome. So that's that. So as you can see, it's not very pointed. If I'd used a larger plate or a bigger piece of cardboard, which maybe I should have used originally, and if I'd done a larger circle, like so. You could also use a frisbee or a table plate or anything else you have in your kitchen or that's readily available. Like I said, a frisbee or another plate, that would work as well. So I still have my hole in the center here from my compass, which is right there. I'm just gonna like cut in from the side. So if I do this, you guys can see that the nose cone is a little steeper. So the one I made with a smaller diameter is not as tall or not as pointed. So it might be a better idea to use a larger circle, and then you can fit it to this. And then if it overlaps too much, you can always cut some off. Sort of like that, and then you're not using as much cardboard, and it's a little bit easier to manipulate when you tape it on, if that makes any sense. So you can see the difference. So after we have the nose cone onto the rocket, we're going to make some fins. You guys might remember some of these triangular shapes from elementary school or middle school. Many of the rockets use sort of an obtuse triangle or a right triangle. A right triangle indicates that there's a corner that's 90 degrees. So most often those are the type of fins that you see on a rocket. So I'm just gonna simply draw. If you want to use your ruler, you can do that. I'm just gonna use the ruler a little bit, and I'm gonna guess the 90 degree. I'm gonna make it a little more obtuse, so it's not 90 degrees. And then I'm gonna draw these lines. So now I have a triangle, an obtuse triangle. So then I'm going to cut that out. That's not bad. All right. Now to get the same shape, I'm going to use this, and I'm going to trace it. So I want to do 2. I won't put it near the edge, but I can do that, and then I can spin it, and I can use the same cut line for 2 pieces. Does that make sense? So there you go. Or you can cut them out. You can do as many fins as you want. I'm going to do 3 fins today, but you could do 3 fins or 4 fins, or however many you feel make the most sense. There we go. And then we have 3 fins, all the same size, roughly. Perfect. Okay. Now for this, now we're going to tape the fins on. Because the nose cone is here, we're gonna sort of tape it on the side. And there's one. So we have 1 fin. Now I'm gonna do the other 2. They want to be about 120 degrees apart because the circle is 360 degrees. So we want to be about 120. We want to be, if this is 0, this would be about 120, and then we have about 240, and then we'd be down at 360 degrees, if that makes any sense. So we want to be somewhere about 1/3 of the way around. We're going to do the same thing. The tape is sticking to the fin, sort of like that. Then we're going to do the other direction, something like this. Now once you get your fins on, you want to make sure they're roughly 120 degrees apart, and if they're not sticking well, you can use a little bit more tape. You may have to bend them a little bit and add a little more tape. That's it. I think actually before I I head out to launch it, I think what I'm going to do is I'm going to remove this nose cone and I'm going to replace it with the larger one that is taller. So that's an easy fix. Remove some of the tape. It's very sticky, but here we go. And then that other circle. This is still too much, so I'm going to use my scissors and I'm going to remove more. So now we're left with this. It'll be a little bit easier to overlap. And if it's difficult, you can always get help. Another thing you can do is draw sort of a line approximately where it needs to be. And then you have two hands, sort of go back to that line, and then you can always ask for some help, or somebody to help you tape it. There's the nose cone. That's better. I like a more pointed nose cone. I don't know if it'll help with it launching, but I think it will. So, then I will discard this, and then I will get a few more pieces, and then start anchoring it to the bottom. So, before you tape these on, the fins or the nose cone, which you can also do, is you can also color them with magic marker or paint. You can paint anything you want on it. You can put your name on it. I'll secure it a little bit better, but that's the gist of it. So it's a little bit taller, a little bit narrower. I'm going to finish taping this nose cone on a little bit more. Then we're going to head out to launch it. Before we launch it, we're going to fill it about a third of the way with water. And we're going to flip it over. Then we're going to use a bike pump to pressurize it. And once there's enough pressure built up in it, we'll launch it. So I hope that's good. I hope it went well. And we'll see you in the back lawn. Thank you. As you notice, the 2-liter bottle of my rocket here changed. We tried the other one and it didn't work well. So we think this Poland bottle has a larger diameter area and we think it'll launch better. So we're going with this one. So, but I moved the nose cone and the fins over and we should be good to go. So again, I'm going to fill the bottle about a third of the way with water. And then we're going to pressurize the bottle by putting it on this launcher. Okay. Launcher. Now we're going to stake the launcher into the ground. Now we're going to put the bike pump on here, and we're going to pressurize the bottle to about 40 to 50 pounds per square inch, and then we're going to launch the rocket. So here we go. You can see the bubbles at the bottom of the rocket. With the air being pushed in, it's pressurized in the bottle. Launch, Annabelle. Okay, launch. Watch. I hope you enjoyed it. We had a nice time. Hope to see you guys next year. We're definitely missing you guys. We typically have a great time at the high school, so looking forward to it next year. Thanks. Have a great week.